Hello everyone. Today we are going to start with the topic sets. So in sets what we are going to do is we need to first understand what is set. Second, we'll know how we denote set. Third is representation of set. And after that, examples. We'll do some examples, some predefined sets mathematically. Then symbols used. Then we'll do exercise 1.1. So before starting with the topic, first we need to understand what is set and why we are studying set. Basically, we'll use set in our next chapter, that is relation and function. So we have use of set in next chapter. Apart from that, we'll use set in probability also. So we know about the two terms, that is event and sample space. So here we also use set to write down the event and sample space. Okay, so let's continue with this. First is, what is set? So set is a well defined collection of objects. So now we need to understand what is well defined collection of objects. We know that when we are collecting some things, that is collection of objects. But what does we mean by well defined? Well defined means the thing whose definition remains same for everyone, or we can say it does not change. Means definition of something does not change. For example, a collection of vowels. Collection of vowels remains same for everyone, so we can say this is a set. What is the collection of vowels? A, E, I, O, U. Then name of days in a week. Is it a set? Yes, because the definition means for everyone name of the days in a week would be same. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday and Saturday. So this is also a set because this is well defined. Let's suppose if I ask you good mathematics books for class 11. Is it a well defined collection? Because someone can collect NCERT, someone can collect RD Sharma or RS Agarwal or Aryan, all in one. So this definition varies from person to person. mean, some students like NCERT, they face problem in RD Sharma, or some of the teachers would say that NCERT is sufficient enough to do all the questions of the chapter. Someone say go for RD Sharma, someone will say go for RS Agarwal, someone will say Aryan, all in one, or someone can say okay, go for together with. So this definition varies from person to person. So this definition is not well defined. So we'll say this is not a set. Clear? Let's look for some more examples. Collection of good bikes. Is it well defined? No. Why? Because this good, this is a perspective. Someone like FZ, someone will like Ducati or Royal Enfield or Pulsar. So this way, different person like different bikes. So this collection is not well defined. This varies from person to person. So this is not a set. Okay, if I say collection of students class 11, is it well defined in your school? Yeah, this is well defined because how this is well defined, I have to collect the name of the students and of class 11 from my school. So this is well defined. I can write down the name of the students in my class in my school. So this is well defined because this would be same for everyone. Let's suppose if I write down collection of dangerous animal. Is it well defined? No. Why? Because someone are afraid of rat or dog or cat or lion or tiger or snakes. So this also varies from person to person. This is also not well defined. So this is also not a set. This is a set. So this way we have understood what is a set and what is not set. Means something which is well defined and which is same for everyone, means definition of the same should not change from person to person, and that collection we can say is a set. Apart from that, we'll say is not a set. Let's suppose if I would say uh, collection of all the rivers in India, is it a set? Yes, because for everyone the rivers in India would be same, there would not be a change. Or if I say collection of factors of number 24, so this is also said because the factors of 24 remain same for everyone, that is 1 2 3 4 6 8 and 12 and 24. So this is also a set. Clear? So till now what we have done is we have understood what is a set and what is not a set. Okay, now let's see how we denote set. So generally sets are denoted by a capital letter, means either A, B, C, D or so on. For example, let's suppose I can write down I have a set A and this set is collection of natural number less than 10. So this is a set because this collection remains same for everyone. If I have to write down natural numbers less than 7, this would remain same for everyone. So this is how I denote a set. And second is elements in a set. are denoted by small letters. For example, the same example, that is collection of numbers less than 10. Collection of natural numbers less than 10. 1, 2, 3, 4, 5, 6, 7, 8 and 9. Apart from this, we can go for another example. Let's suppose set B, that is collection of vowels in English alphabet. So how would I denote? These are known as the elements. These are known as the elements of the set. So how would I write down? A, E, I, O and U. So these are my element, and this is how I am denoting the set. Set is denoted by a capital letters. So, and these are the elements of the set which we denote by a small letters. Okay, and if there is a numeric elements, then it doesn't matter means how we are denoting it, because on there is only one way of denoting numeric letters, that is 1 2 3 4 5 6 7 8 and 9. So this is how we denote set. Means generally we write down set in capital letters and elements of the set in small letters. Okay, now let's see how we represent set. Representation of set. So generally we represent sets in two forms. One is in roster or tabular form, and the second one is set builder form. Now, what is roster form? So one way of understanding this is roster means something roast, and roast means in Hindi something means ready to eat, or we can say paka pakaya. So in this we'll get directly the elements of the set. Tabular form means the things are tabulated or things are given in tabulated form. For example, directly I would see set A, natural numbers less than 5. 1, 2, 3, 4. So these are natural numbers less than 5. So this is roster form. The same thing if I have to write down in set builder form. So set builder form is there would be a statement. On the basis of that statement and condition, we need to build the set. For example, the same thing, the same situations I would write down in set builder form, that is set A, elements are X. So in set A, elements are X. X is a variable over here, such that, so this symbol represents such that X is a natural number. So X is a natural number. Second, the condition is X is less than 5. So inside builder form, what we'll get? How the elements are represented, the definition of elements or type of elements, and the condition. Let's suppose if this condition is not given, only this is given, set A such that X equals to X, X such that X is a natural number. Then in set A, in this initial, that the first one, the elements would be 1 2 3 4, and in this set the elements would be 1 2 3 4 5, and it goes on till infinity. So see, in this set number of elements are fixed, or we can say defined. In this set number of elements are not fixed, it's not defined, or you can say infinite. So that comes as, I can say this set is a definite set and this set is a infinite set. So this set is a definite set and this set is infinite set. So what is definite set? A set in which the number of elements are fixed. An infinite set, a set in which number of elements are not fixed, means its number of elements are infinite. An indefinite set, number of elements are finite. Okay, so till now it's clear, I hope. Okay, so let's move on to the next part. Representation of some predefined set. Representation of sets mathematically. So there are few symbols inside which we'll use, that is n, collection of all natural numbers. Okay, z, collection of all integers. So in this, integers can be positive. So positive integers are denoted by z plus, and integers can be negative, which is denoted by z minus. So instead of z, in z we include both positive and negative integers, and if we have z plus, only we are talking about positive integers, and if we have z minus, only we are talking about negative integers. Similarly, q, collection of all rational number, r, collection of all real numbers. So I hope you know about what are natural numbers, integer, rational numbers, and real number. So if we are using n, then means why we are understanding this is because in set builder form we'll be using something this way. Let's suppose means I am writing down there is a set A, elements are x such that x belongs to n. So we'll talk about the symbol now. This is x belongs to n and x is less than 10. So we need to know what is n means. Let's suppose if there is written x belongs to r or x belongs to q. So we need to understand this. So now what this numbers represent means n represents natural number, means collection of all natural number, r represent collection of all real numbers, q represent collection of all rational numbers. So if suppose it's written r plus, collection of all real positive numbers, r minus, collection of all real negative numbers. So similarly, just plus minus sign denotes what kind of numbers, means positive or negative numbers. Now the thing comes is the symbol. So this symbol is a Greek symbol which means epsilon, and in this context it means belongs to. This epsilon, this means belongs to. So let's see an example, from there we can understand. So there is a set A, 1, 2, 3, 4 and 5, and there is another set B which is 2, 4, 6, 8 and 10. So now there is first question A. First question is there, that is I can write down 2 dash A, 2 dash B, 4 dash A, 8 dash A, 10 dash B, just to give you an idea, 6 dash B. So now the element 2 is part of set A, is it? Yes. So I would say element 2 belongs to set A. So this way we write down epsilon over here. Means element 2 belongs to set A. Element 4 belongs to A. Element 4 belongs to A. Yeah, element 4 is also part of A. So I will write down element 4 belongs to A. Element 2 belongs to B. Yes, element 2 belongs to B. Element 8 belongs to A. No, there is no element 8 in this set. So I would write down does not belongs. So this symbol is belongs to, and if I cross this, this is doesn't belongs to. Clear? So element 10 belongs to B. Yes. Element 6 belongs to B. Yes. Okay. So I hope we are clear with this part. Okay. So now let's do some questions. Example, representation in roster form. So means there would be a question which is given in set builder form. So and we have to go in a roster form. Okay. So first there is a set A X such that X belongs to natural number and X is less than 10. So this is given in a site builder form. So I have to write down this in a roster form. A. Now X is the element, X is a natural number. So if we have only this two condition, this side becomes infinite because there are infinite natural numbers. But because of this condition, our set becomes finite. So there are infinite natural numbers, but in this set only natural numbers are less than 10. So this is 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay. Let's go for another example. A such that is 3x such that x belongs to natural number, comma x is less than 5. Now in this set our elements are representing 3x means multiple of 3. In previous set our elements were representing only x. Okay. Next condition is x belongs to natural numbers. So here we can put only the natural numbers means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and so on. But again there is a condition that x should be less than 5 apart means these two conditions simultaneously work together means x is a natural number as well as x is less than 5 means x can be 1, 2, 3 and 4. So the elements of set would be not 1, 2, 3, 4. We'll substitute x over here. So 3 into 1 is 3, 3 into 2 is 6, 3 into 3 is 9 and 3 into 4 is 12. So this is our set. Okay. Let's go for another example, that is set B x such that x belongs to integer condition x square is less than equals to 9. So write down the elements of the set. First you try it yourself, then you can go for the solution. Now just go step by step. What are the elements in set B? Elements are in the form of x. Okay. Now x belongs to integer. Now the condition is that x square should be less than equals to 9. Okay. So first element I can write down is 1. 1 is an integer. 1 square is less than 9. Okay. Second element I can write down 2. 2 is an integer. 2 square is less than 9. Okay. Third element I can write down 3. 3 square is equals to 9. So our condition is less than equals to 9. Can I write down 4? No. Why? Because 4 square is 16 which is greater than 9, not equals to or less than 9. Only this much. Can we write 0? Yes, we can write down 0 because 0 square is also less than equals to 9. Only 4 elements in this set. Or can we write down minus 1? Yes? Yeah. Minus 1 square is also 1 which is less than 9. Similarly, we can write down minus 2 and minus 3. Okay, so these are the elements in this set. So this is how we go. There are situations given, means how the elements are represented, the definition of the element, and the condition. Let's suppose if condition is not given, what would happen? X belongs to natural number. So in this case, our set C is infinite set. It goes on 1, 2, 3, 4, 5, 6, and so on. Because of this condition, we get finite elements in our set. And if this second condition, or you can say second condition, is not given, we can have infinite elements in our set. Clear? Okay. Now let's go to next. Now in this, we'll see example from roster form to set builder. Okay. First is, let's suppose I have 2, 4, 6, 8, and 10. So these are the elements of the set A, and we have to write down this in the form of set builder. So first, what is the syntax? Means how we write down in set builder form. That is, let's first understand the syntax. That is A. Then we define element, then type of element, then the condition that X is less than 10. So this is how we write down in set builder form. Now for this set, how we'll write down is A. Now elements, if you'll observe, are multiple of 2. This is 2 into 1, 2 into 2, 2 into 3, 2 into 4, 2 into 5. So my elements would be in the form of 2x. Clear? Such that x is a natural number. Fine. Now the condition would be x is less than equals to 5. So now if you'll observe, x is a natural number, x is less than equals to 5. So what are the values of x we can have? 1, 2, 3, 4 and 5. Okay, now substitute value 1, 2 into 1, 2. We are getting the first element 2. 2 into 2, 4. We are getting the second element. 2 into 3, we are getting the third element. 2 into 4, we are getting the fourth element. And 2 into 5, we are getting the last element. Fine? Okay. Now go for next example. Set B. 2, 4, 8, 16, 32. Observe the element. Write down this set in set builder form. First give it a try. Then continue with this. So let's write it down. How will write? Set B. Now again, if you'll observe, now these are not multiples of 2. Because 2 into 1 is 2, 2 into 4 is, 2 into 2 is 4. But 2 into 3 would be 6. Here is 8. So these are power of 2. 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the power 3 is 8, 2 to the power 4 is 16, 2 to the power 5 is 32. So in this set, our elements are in the form of 2 to the power n. Okay. Now the next condition, n is a natural number and n is less than equals to 5. Clear? Okay. Now one more example. 1, 4, 9, 16, 25. And so observe the elements in this set, and how would you write down this set in a set builder form? What was the relation? Okay, so if you'll observe, this is the set of square numbers. So how would write down C, that is x square, such that x is a natural number and there is a no third condition, because this is infinite set. So this will keep on going because x is a natural number 1, 1 square 1. X next natural number 2, 2 square is 4, 3, 3 square is 9, 4, 4 square is 16, 5, 5 square is 25, 6, 6 square would be 36, and it would keep on repeating. Sorry, it would keep on going in the same way. Okay. So in this video, what we have done is we have understood what is set, denote, how we denote set, representation of set, then some predefined set that are mathematically, and symbols. Then we have see means we understand what is definite and indefinite set. Then we have done some examples on the same. Okay, so I hope we are clear with what is a set. Set is a collection of well defined, means set is a well defined collection of objects. Means well defined means that the definition of the same should not change. It should be same for everyone. It should not vary from person to person. How we denote set? Generally we denote set by a capital letters and the elements of the set by small letters. Representation of set, we can represent set in two ways. One is roster form and the second one is set builder form. Predefined set, we have seen predefined set n collection of all natural numbers, q collection of all rational numbers, r collection of all real numbers, and symbols we have seen is that is epsilon, which is belongs to, and this one is does not belongs to. Definite and indefinite set is, definite set is a set in which the number of elements are fixed, and indefinite set is number of elements are infinite, and we have done some examples on the same. So I hope we are clear with this part. So once we are done with this part, you can practice exercise 1.1 NCERT. NCERT. Okay. Hope you all liked this video and enjoyed this, have cleared your doubts or understand the topic. If you all enjoyed it, please give it a thumbs up, subscribe to my channel, and share it with your friends. Thank you. Bye bye.